I don't know why what was the problem there. Right. So we had a discussion on this spatial diversity where we had a one of the part which was array gain. Array gain is nothing but the information about measuring your signal to noise ratio. Signal to noise ratio, why we are going to measure? Because we need to identify the loss or noise ratio present in that particular signal. So that we need to measure. So that is why we are going to have this. Now the expression what you are going to observe in this is that yi, which is your signal to noise ratio, it is been calculated by these expressions. Okay, and we have assumed few values we have considered, and finally we got expression which is this value, and by this we are going to tell whether it is what is the array again present in that particular thing. So receiver signal also increases linearly with the number of received antennas, even if those antennas are correlated. So that is one point which has been highlighted in this for the multiple antennas with respect to the spatial diversity. Then we had a discussion on the concept of the diversity grade. So here they calculated which they have measured in terms of bit error probability. So which is given by this PB, right? So he has considered C1, C2. Again, he is dependent on this signal to noise ratio, and it is a function of the exponential. So exponential, why it is taken? Because you want to have a 360-degree, which is nothing but your sin theta, right? So that is why they have taken this one. You may be asking, sir, how they have found out this expression? It is not that found out that expression. So they found that it is suitable. Okay, they found that it is suitable to measure the diversity gain by using this expression where you are having the complete 360-degree, right, which is your exponential function. Why here it is exponential function? Because so if I'm having a power, so this power over a period of time when we are using it is going to be decaying, right? So it is gradually decaying, or it may when we are charging that part it is gradually increasing the particles, right? So to have these measure, so they have got for this exponential term. So why they have taken only this term? They could have taken sine term, they have taken the cost term, you may be asking, but those six are not present because for a what I will tell is that the authors, researchers, they have experimented these six with different function, and they come out with this expression, which is most suitable for the wireless technology. That is why they have taken. So nobody will give in their textbooks that how I have imagined or how I have done. So I have taken this one and I have experimented. So if you want to, you are having better results compared with this function, you can include that one and you can tell. That is what I can try to tell in this diversity grid. I have no other option for no theory I'm having. Sir, why we have taken with this expression only? Okay, so this is they have given because how they have got, obviously they would have been studied, research would have been gone through that, and finally they have concluded the bit probability error can be find out with this one. So obviously you are going to observe whichever technology or whichever method you are going to implement for this wireless technology, you are identifying the faults present. Okay, the fault present can be with respect to the energy. The fault it can be with respect to the error probability, or fault it can be with respect to the noise present, or fault can be with respect to the interference which has been added. Right. So I am having information, I am transmitting, so that information will be affected. I am not sure, I am not telling that it will be not affected. That is what we are trying to tell you. So whatever I am doing in the lecture, I am not telling that 100% everyone will listen and 100% everyone will understand. Okay. Those who are concentrating, those who keep the textbook with along with them, those who observe, and whatever I have discussed, and by evening they open their textbook and if they read it, so they will try to understand that Oh, this is the concept how it is with freight. But nobody actually now at this point of time have time to go and check these things. Only they bother about that. If this is important question, so how I have to prepare it, what content I should put it so that I will get maximum marks. Okay. So when you think in that way, so your understanding or limitation of the concept will be very limited. Right. And if you want to go to in-depth, so only one textbook it is not sufficient. You have to go for the multiple theories and you have to conclude what it is. Right. So that is how it will be presented here. So again in this diversity gain, we have taken this gamma 1 value, then ND equal to NT and NR, so gain of the transmitter and receiver, and which has been given for the device. That is why we are having this ND, and this they have substituted here, which we are going to get it as PB equal to approximately equal to. It is not again equal to. So whenever probability interference it will be there, it is only approximated. It cannot be an exact value. Okay. I have corrected, so there will be by limitation. You have corrected from your device, there will be some limitation. So I may get a value of 1.5, you may get a value of 1.2. So there is a difference, right? So those are all calculation will be there. But here we are measuring how we are doing. So this is the equation 1, equation 2, and equation 3, which is been highlighted here. So those waveforms, you can observe that n equal to nr value, nd value, or nt value, or different value, how it is going to do. So how we have got, obviously exponential function, so it will be decaying part for a period of time, it will keep on decreasing. Right. So that is what here given. So only looking at this waveform, we cannot tell, right? So we need to have the calculation part, we have to transmit the data. So in the real time, who will do this? Okay, who is going to experiment this? How they are going to do this? And how we are going to do? So nobody will try for the real time thing. Everyone will go for the simulators, and those simulators will be not easily available for us because we cannot uh, purchase those software which will be very high end. So when we go for the networking companies, so there they will be having their different softwares where they are going to test these data. So how they are going to test these data? So they will build one scenario where they are having this channel, they are having multiple transmitters, they are having multiple receivers, and they are having multiple antennas. Right. So all they will introduce themselves and they will have some data and they are going to transmit using these channels. Right. And they will observe that without any interference. So what is the efficiency of rate of transmission from source to destination? So if I introduce any losses in these antennas, so what is right? And simulation result at the real time, obviously they will be having some variation. So that variation they are going to observe it and they will release in the market, which is going to be used to us. That is what they are trying to highlight here. So these waveforms will be helpful in identifying to know what type of data, how much time it is going to take, how much interference will be there. Now for the ideal case, for no interference, what is the data rate it is going to take. So that is what if I want to purchase any vehicle, they will tell that star 100 kilometer per hour, 80 kilometer per hour, right? They will tell, but indicate that star. What that star? Under testing condition. What is this testing condition? So there will be no hubs. So they will not apply any brakes. Right? So when I have all this star condition, so what happens? Your mileage will increase. That is why they will tell 100 kilometer per hour. And with the real time when I do, not even it will come around 50 or 60 kilometer per hour. Why it will not come? Because here you will having a real time scenario where we will be having a in between adults will be there. You are applying brakes, so you are changing the gears, and all those things we are going to do. So what happens? Naturally, your mileage will be decreased. Now in testing condition, it is 100 kilometer per hour. Now in the real time scenario, it is not even reaching around 50 kilometer per hour. Right. So you have these two conditions. This is with respect to the vehicles which I am speaking. Right. Now say things if it is with respect to the channel, wireless channel. So you are having multiple devices, you are having interference. Okay. All those six should be considered and done. So here also we are telling that in real time we will be having some interference which we need to cope up. Right. There is no method like. Right. How to improve this one? Still, research is going, new methods will come, so which they are going to highlight all these things. So this is one of the diversity technique which is been given. Then here a different methodology to cope up with these type of issues. So one of the issues what they have given is that increase coverage or reduce transmit power. Right. So I want to transmit, if I transmit more of the things, then what happens? I will be having less issues. That is why I had said the previous example also. So everyone now telling that it is second wave which has been spread. Right. So this is the issue which we have. But prior to this issue, whether government has not taken any initiative to stop this, whether World Health Organization they have not initiated, everyone has initiated, but we were not convinced. But they had said that you take the vaccine and you do compare, you have the vaccine. But nobody was ready to take up the vaccine during those periods. Everyone was having a fear whether we need to take what will happen next and all those things. So for that vaccination also, there will be a time lapse, right? So what that it is that if you are not ready to take up, so we will sell to the abroad. But they exported everything. Now what happens? Second way, more people are dying, more people are affecting. No, there is no other way. Only left out is that we have to go and take the vaccine. Now when everyone has have their bet, they have changed their bet and they want to take vaccine. Now there is a shortage of vaccine. Right. So these are the issues which is there. And obviously nobody will directly go and take the vaccine. They will inquire which one, which to take, which is available. All this information when they try to do, then they are going to do. So that is also we are going to apply here also. Right. So if I give more than sufficient to this one, so then loss will be very minimal. But if you plan it properly, and if you have minimum number of interference, so then what happens? Your efficiency will be very high. So why that I'm saying? Because if I build a wireless channel and if I have limited number of transmitter and limited number of receiver and I have limited number of antennas. So everywhere I will be able to know I can track it. So how much time it will take from this point to reach to this antenna, from this point to reach this one. So this much if I am able to calculate and measure, then sufficient energy if I give, then obviously there won't be any loss. And I'm not sure how much distance it is there to the reach to the destination and I have given minimum number of power, then what happens? Then only your loss you are going to occur. That is why it's telling increase coverage or reduce transmitter power. Right. So how you are going to do? So that you are going to do with respect to these expression which is given with respect to the receiver antennas which is calculated as NR. Right. So you calculated this one, you calculate what is the power and use sufficient. That is why we will tell that I want to travel from my home to the college. So they will give sufficient amount of money to me. So 100 rupees, whether it is sufficient to reach from Mathikara to college, that is sufficient if you are traveling from the bus, right? PMTC bus, if you take, it is more than sufficient 100 rupees. But same thing, Mathikara to college, if I wanted to go, if I'm using a cab, so obviously it is not sufficient, right? So there is a loss. So those are the things which is being taken care here. But this is with respect to the wireless compared to the real time. Okay. Increase the data rate with spatial diversity. So which is nothing but he is telling that you increase the bandwidth. So if you increase your bandwidth, then what happens? It is more than sufficient. So for this Teams 2 GB with video, it is able to do because 3 days back when we had this IA part, so I was enabling the video. You people all were enabling your videos. So the bandwidth which was taken when you enable videos was at 2 hours, 2 GB, it was coming to me. Right. And when I'm not enabling any videos in the Teams, so I will take around 4 to 5 hours without any interrupt. So with enabling video part, it was only taking around 2 hours of time. So 2 hours I was having a rate of 2 GB with enabling your video. Right. Without enabling your video, I can have around 4 to 5 hours. So bandwidth if you increase, so more option and all those things. So obviously Teams if you take, WebEx if you take, whichever you take, if you want to reduce your frequency or bandwidth if I want to minimize, so you should disable your video, right? That is the thing. So to do that one, you should know what is the capacity, and that capacity is been calculated by this C value. And this C value was also present in your ITC. We were calculating channel capacity, right? C equal to B log of 1 plus gamma. So this gamma again here introducing the noise. In information theory and capacity, there was no gamma there. There was only channel capacity C equal to B log of 1 plus N. That was the thing which was been present, where N was number of channels it was introduced. Now here gamma it is telling because you want to find out the signal to noise ratio of that particular channel. So that capacity was been identified by this expression which is given here. Okay. So then we had two methods. One is receiver diversity, one is the transmit diversity. Receiver diversity, again you are having different techniques which we are trying. So here you can see there is a device, right? There is a ENB receiver. So you are transmitting into a multiple part. So you are combining these two and we are having these waveforms. Okay. This is the present which I are doing. So which device I need to give? That is what I was trying to explain earlier also. So if I want to transmit information, I need to select few people whom I can trust, and those people will be definitely taking that information to the complete class. So if I want to pass some information, so I will give to the CR and CR will communicate to you. And if I tell or if your CR also tell, you are having some authentication that oh it is true. Okay. If I tell to some X person if he communicates, that X person if he is not a seer, then what happens? Many people whether they will believe or not believe, that will be a question mark. I am not telling that he will tell false. I am telling that how many people will believe, that is bit question. And many people what they will do is that they will directly contact to me only, sir, whether it is correct or not. That is the thing which has been present. And I am also, if I'm not sure, they will go to the HOD level. They also not sure, they will go to the principal. And if they tell it is true, means we need to believe that it is a correct value. So these are different receiver diversity techniques which has been present. And performing this operation, we have few of the terms, right? Which we call it as a selection combining, which we call it as a maximal ratio combining, right? So selection combining is the one which will be selectively be selected for the transmitter, which is to be, because I was giving an example that we have multiple types of data transmission. We have image, we have text, we have numerical value, we have video, right? We have audio. So these require different types of system to produce. So if image is there, that image I cannot open in the MS Word, right? That image I need to open in the Paint, or image can be open in the format which has been present. So you might be observing there are different formats like JPEG format, PNG format, black and white format, right? So they have PDF format. They have n number of types. Audio format if you take MP3 format, MP4 format, right? Multi-processor, multi-signaling part, right? We have 2.2 point, uh, sorry, 0.264 format, So all this format they will allow. So in by default, in my laptop, there is a Windows Media Player, right? And few of the images or few of the movies, if I want to play with those things, it will not allow. Okay, so I will install VLC player. So all types of format will be playing. Can you tell me what is the difference between a Windows Media Player which has been inbuilt by the system and one extra which I am adding, which is VLC player? So for us people, what is it? It should view properly, right? And it should play any kind of things. And if it is viewed properly, then there is no issues. Okay, but it is not that that is a thing. Now, technicality, what I want to tell highlight here is that VLC will play you, but Windows Media Player will not play you. Okay, so what is the difference? Why it is? Because sir, people, students will tell, sir, this kind of file it is not supported by this Windows Media Player, and these files have been supported by this one. You will tell that answer. Normal person also will tell that one. But as a technical engineer, you should be able to tell why it is not able to play in this type and why it is able to play in this type. So when I observe that one, what happens is that your player, Windows Media Player, which has been inbuilt by the laptop, right? So they have given preference to that one. They have not given preference to VLC. Why? Because they will tell, sir, VLC is a product of other company. That is why they have not taken into consider. It is not that way. Okay. So Windows Media Player, they will tell that these are the types of files which can be played. So that will be present in their website, and every information they will tell. So this should be the file format, this much it should be there. And why they are taking that one? Because that will be a licensed version. And second thing will be of it will consume minimum number of power. Right. So those are the few technicality things which has been there. And that is why they will support those things. Right. And sir, why they are not going to play all other formats? Because it will consume more power and more encryption, more decryption process will be there. So more power will be utilized. So how I want to have high efficiency. My laptop, sir, 24/7, I should attach a what power charging to this one. Otherwise, it will go off. Why it will go off? Because of all these things. These technicality things we will not bother. Only what we see is that whether it will play or not. That is how it is in the real time. So these all things again, what I will tell is that when you go in depth in research, when you go, so you will be highlighting these things. Many of you things will be, sir, this is very simple. So there is a transmitter here. So there is a selection best antenna is somebody will be there. So he will be selecting that one and he will be giving. Yes, that is there. But how you are going to do it? How it is how it will be made possible? So those observations we have to see. So see when they are going with this antenna, what is the waveform, how it is there. So all this waveform they have given. So by this we will come to know, right? And by default they will set. So that is why for your mobile phone and all those things, they will be default setting. But default setting means what? Which is most appropriate, so that will be set as a default setting, right? So that is present in this. Obviously selection combining name only it will tell that, so it is going to select which is most important. Maximal ratio combining means what? So there will be 10 multiple ways to transmit. You will take maximum how many are transmitted, and that will be selected. Okay, maybe you might have observed in that have you observed that Milapa? So in that Milapa, what you will do is that, so you will be able to make a donation and you can create that one, and you will can share that one using your when you are sharing information, and by seeing your shared information somebody has paid, so that will be credited to you. Okay, that will be credited to you, and that person if he shares to other person and that is linked, so there is a again sharing to you only. So many techniques will be there where they are using this one. So if I am this person, so I am sharing to these many people, one, two, three, suppose say, right? You may be with a Google Pay or Phone Pay. If you do also same thing, you are referring. Many people will tell that when you refer, you will have a benefit. So I referred these three people. So if they contribute some amount, some percentage of amount will be benefited to me. And if they people again if they refer, okay, again if they refer, right, and if this person, if he pays some amount of money, some percentage will be benefited to him, and some percentage will be benefited to him. Right. So this is how we are going to do. And the credit should be given to all, right? The one who has initiated for him also it should be there. So the percentage varies, right? So here is 10%, here is 10%. So I'm taking an average. That is why we call it as a maximum ratio combining part, MRC. So I am going to do the sum value, right? And that value you can observe here. Right. So there is a slight difference in this waveform. So here you see it is only selecting the best antenna, and here you can see there is a summation part. Okay. So there is a difference between these things which can be observed. Okay. And pertaining to this one, what is a waveform that you can observe here? You may be telling, sir, there is no way both looking same, but there is a different values over here which is been present. Okay. So this is one of the receiver part. Then we started with the transmit diversity, where we discuss about the closed loop and we discuss about the open loop. So closed loop, so we are having this part, transmission part. So you can observe one we were transmitting in a sine function, one was with respect to the out of phase cosine function. So between these two, again data was being retrieved. So when I am doing a closed loop operation, one data in 90 degree, one data I need to do out of phase. You can observe that in the waveforms which is being presented, right? So they are doing some particular thing, that is why they will tell us. Okay. So you are calculating these values, right? And to have these values, you are going to have a matrix value. And that matrix value we are trying to identify, and which we call it as a spatial multiplexing. So again you observe that x1, x2 plus n1. So they are taken here two antennas. Earlier I was taking y1 equal to h1x plus ni. Now here it is what? H1, X1 plus H1, X2 plus N1. So he is writing here values in some matrix form. Why matrix is useful? Because we have calculated matrix method. It is easy for us to identify the error, which we are calculating with respect to the H value. Okay. So spatial multiplexing, he has given some values. H1 equal to zero point 0.8, H2 1.2, H1 2.6, H2 2.4, X1 is plus 1, X2 is minus 1. Why there is a phase shift? Because you are transmitting same signal with phase and without phase. Okay, so that is why plus 1 and minus 1. Right, when I substitute this value, your output y1 and y2, when I substitute this expression, I am going to get it as 0.22 and minus 0.22. So these values will be very much same. That is why in the, hope you remember that in the information theory and coding, entropy we were calculating. And entropy when we are measuring, if even if it was a negative value, we are doing a modulus sign, and that modulus sign will make your negative value to a positive value. And why it is a positive value? Because it is a information, and your information cannot be a negative thing. Negative information, it won't be there. Negative feedback will be there. Information will be present, right? That is the thing. There will be a information present, or there will be a no information. You cannot have a negative information. Don't think that negative information giving or saying bad things about that person is negative information. ಆ ತರ ಅಲ್ಲ. It is just like a imaginary values which will be there. Imaginary values, whether they are present or not, we are not aware, but imaginary values will be present. That is why we are going to take that exponential term, and where we have cos theta plus j sin theta, where j is your imaginary term, and imaginary term will be present because of that value. So it is again related to N where you have more technicality things present over that. Okay. So these are the topics which I had covered till now. Right. So uh, to be frank, till this point, we have stopped it to this slide, y1 and y2. He has taken one example here where he measured this x1 cap and x2 cap also. So what he has done, he has taken this expression. So I know how you can take this one. I can want x1 value. So x1 value you can calculate it by y1. You need to take minus of that one divided by h11, which is nothing but which is done here, right? Which is done here. So these are the expression which we can calculate. So sometimes in the information theory coding, input will be given, output you measure. Sometimes output will be given, input you are measuring because it is once both same, right? You are transmitting from this side also, there will be a chance of noise. When you are transmitting from the receiver and also, there will be a noise. That is why we will tell uplink and downlink both at the transmitter section, both at the receiver section. Those things are present. And that is why you are able to calculate y1 and y2 also, and you are able to calculate x1 and x2 also. And why this is plus 1 and minus 1? Because there is a phase shift which is applied. But values you see it is same. You will not get x1 as 1.1, x2 as 1.3 or 1.1 or zero point 0.9. It will be same, only the difference will be the sign. And why there is a sign difference? Because of the out of phase. Okay. So open loop problem we'll be discussing. Open loop spatial multiplexing, then closed loop multiplexing, then matrix representation, then implementing issues, interference cancellation, choice between diversity interference and spatial multiplexing. So these are the four topics which have been left out, and these four topics we will be covering in the next class. Okay, so I'll take the attendance sheet. Right. And one more information. Just I will stop this record.